In this video, we're going to talk about logarithms and introduce you to what they are and the basic definition and some problems you'll need to be able to solve. So what are these things and why do we need to learn them? Basically, all logs are exponents. That's simply all logs are. So for example, if I wanted to know 2 to the what power is going to be 10, right now we don't know exactly what that is without guessing and checking. We can say, we know 2 to the third is 8, and we know 2 to the fourth is 16, so it stands to reason that we would have to pick an exponent that's in between 3 and 4 to get an output that would be close to 10. So maybe it's, 2 to the 3.1, maybe it's 2 to the 3.2. We'd have to kind of guess and check using our calculator and see what will give us something pretty close to 10. The only way we're really going to find it is if we were to actually use a logarithm. They're also going to help us solve problems like the following. How long would it take for us to have $100,000 if we had an initial principal only of $5,000 at a rate of 2.25% compounded continuously? Let's set the problem up. If you know you're compounding continuously, hopefully the first thing that pops into your head is that PERT formula, A equals P times E to the power RT. So if we plug in all the values we know, we want a final amount of 100,000. Our principal is only 5,000. We're going to have to invest for a long time, especially with only a rate of 2.25%. And then it would be E to the R. Now R is the percent as a decimal, right? So it's going to be 0.0225. And then what we're trying to really figure out in this problem is T. How long is it going to take us to get there? Now, again, the only way right now to potentially solve this is to guess and check. We will, at the end of this whole lesson, figure out how we can find what that T value is exactly, as accurate as we need to be. So what is a logarithm? Let's define it. Let b and y be positive numbers, and let b not be equal to 1. The log of y with base b is written as log base b of y, and it's defined as follows. Log base b of y equals x if and only if b to the power of x equals y. The expression log base b of y is literally read log base b of y. So you'll notice there's kind of two ways of writing these things. This form here, when you actually see the word log, this is logarithmic form, or I'm just going to write log form for short. And this way of writing it is exponential form. An exponential form. Now, everybody, including myself, I have a much easier time understanding exponential form than logarithmic form. And so to me, I always kind of emphasize to my students the most important thing you can do for yourself when you try to understand logs is know how to convert between log form and exponential form and vice versa. Usually you want to change it into exponential form to solve the problem because our brains, or at least mine, I like seeing exponents rather than logs. And so then we'll be okay. So let's go to the next slide and practice a couple problems here. Okay, so just what I was saying before, the most important thing you can do for yourself as a math student in these logs is learn how to go from logarithmic form into exponential form. Okay, so just as a little cheat sheet, remember if we had log with base b of y and that equals x, the way you write that in exponential form is, and the way I remember it, guys, is this is your base, right? This is the base of the log, and that's I think why they use, at least in this book, the letter b to stand for the base. That makes it kind of easy because when you write it in exponential form, b is still the base of your exponent. But remember, logs are equal to exponents, so this guy is the exponent. So it's the base raised to that power that the log is equal to y. So the easiest thing for me again is always to start with the base, and I know the exponent of the base is what the log is equal to. So that's what I put up at the top. So let's see if we can rewrite a few here. I'm going to do all of these in detail. So if I have log base 3 of 81 equals 4, I know the base of my log is 3. So in exponential form, I'm going to start with 3 as my base. I know the log is equal to the power that the base is raised to. So 3 to the power 4, and that's got to equal 81. And if you think about it, that is absolutely true. 3 to the 4th is 81. So I know I've done it correctly. Let's take a look at another one. If I have log base 4 of 1 equals 0, I know I start with the base of the log, so I'm going to have the base of my exponent be 4. Logs are equal to the exponents that the base is raised to, so I have 4 to the power 0, and that's got to equal 1. So let's do a couple more. I have log base 9 of 9 equals 1. So another thing a way of thinking about it is the log of this number is equal to the exponent. This is always going to be my exponent that this base is being raised to. So once again, the base is 9, my exponent's 1, and that equals 9. 9 to the first is 9. This one's a little bit trickier. The log base 10 of 0.01 equals negative 2. So the log of the number 0.01 equals, this is the exponent for the base 10. So 10 to the negative 2 equals 0.01. Now that one's not as obvious, but if you think about it, it is actually true, because 10 to the negative 2 is 1 over 10 squared, and 1 over 10 squared is 1/100th, which is 0.01. It's the same thing. And E, my base is 1/4, so I'm going to have base of my exponent be 1/4. Now if I raise that to this exponent, I'll get 4. And once again, this one maybe is not quite as obvious as some of the first ones, but if you distribute that power, you get 1 to the negative 1 over 4 to the negative 1. And if you then do the reciprocal, because they have negative exponents, you get 4 over 1, which is, in fact, 4. So one of the things I'm going to ask you to, I know I usually put the self-quiz at the very end of the video. This is your self-quiz, or at least part of it. So you might want to pause this and try a couple of these right now, and then go ahead and resume the video. A couple more things I would like to talk about in this video is some special log values, and we actually kind of hit on some of them without really talking about it in the last example. Once again, anytime we're doing logs, we always assume the base of the log is positive and it's not 1. Anytime you take the log of the number 1, it's 0, because if you write this in exponential form, b raised to the 0 power is in fact just 1. Anything to the 0 is just 1. So anytime you take the log of the number 1, you will get an output of 0. That's kind of nice. If you take the log base b of the base, you're always going to get the number 1, and that is because if you raise the base b to the first power, you're always going to get b. So those are just a couple nice log values to know. And now what we're going to do, it's a pretty nifty thing. We're going to evaluate some log expressions, just kind of utilizing some values of logs that we know. So for A, if I have log base 2 is 64, what I'm going to do is rewrite all this stuff in exponential form. So one of the ways of thinking about part A, if it was log base 2 of 64, what I like to do is rewrite that in exponential form. So I want to know what that's equal to, right? I want to know what is the log base 2 of 64. If you write that in exponential form, the base is 2, and I want to know to what power should I raise that guy in order to get 64. And if you know your powers of 2, you would know that that is 6, because 2 to the 6th is 64. So the answer to the question is 6. The log base 2 of 64 is 6. So I think what the book was writing here when they rewrote this is really just writing this in exponential form, and they were saying, okay, 2 to the 6th power is 64, So that means our answer to this question is 6. The log base 2 of 64 is 6. So the key, once again, to evaluating logs is to write in an exponential form. So for part B, if you have log base a half of 0.25, really what you're asking yourself is 1/2 to the what power is going to give me 0.25. Again, if you want, you can always start by writing it like this. Log base a half of 0.25 equals what? Right? That's what we're trying to find. And so if I write that in exponential form, that's what I'm getting there. And this one's not maybe as obvious, but if you think about it, I believe if you square that, you're going to get a fourth, because a half times a half is 1/4, which is that decimal, right? So the answer here, the log base a half of 0.25, is just 2. Let's look at another one. If I have log base 1/3 of 27, really what you're asking yourself is what do you raise 1/3 to get 27? So log base 1/3 of 27 is what? If you write that in exponential form, you're saying, okay, 1/3 to the what power is going to be 27. Now some of these aren't super obvious, but once you get the hang of them, they're not that bad. The answer to this one is going to be a -3. And that's because if you distribute that exponent, you're going to get 1 to the -3 over 3 to the -3. And if you do the reciprocal to get positive exponents, you're going to get 3 to the +3 over 1, which is in fact just 27. So the answer to this one is -3. Finally, for D, log base 4 of 2. Well, again, if you think about this and say, all right, what is that going to be equal to, and write this in exponential form, you're saying 4 to the what is going to give me 2, right? So, that doesn't seem like there is an answer, right? How do we do that? It can't be anything bigger than 1, because if we square 4, raise it to the third, it's going to get bigger. And if it's negative, that might just do some reciprocals. I'll get fractions. But I know the square root of 4 is 2. Do you remember we can write square rooting as an exponent if we raise it to the half power, right? 4 to the half power is the square root of 4, which is in fact 2. So log base 4 of 2 is a half. So some of these, I don't know, I think they're kind of fun because they can challenge you a little bit on how to go about finding some of those exponents. So to finish off this particular video, I want you to try to see if you can evaluate the log expression. Again, my hint to you is to say, okay, what does this equal to? And then write that in exponential form, right? Like 5 to the what power is 125? And I probably shouldn't have done that. I'm already giving you too much of a hint. And same thing for number 4. See if you can determine those, and we'll talk about it in class. Thanks for watching.